ASUS makes 3 Hyper M.2 x16 cards. Today we're going to take a look at version 2. Anybody have any idea what the difference is in these 3? Will it work in your computer? And why would you want to put it in your computer? Will it work with your chipset? What's bifurcation? What does it take to make bifurcation work? Folks, welcome to Build or Buy. I'm your host. My name is Gil Boyd. I want to thank you for joining us. Today we're going to take a look at the ASUS Hyper M.2 x16 card. Now we've already taken a look at the first version, and I've got 7 links I'm going to share with you that we'll put up in the description in case you want to kick to the chase and see the details. But for those that are searching the information, I will say if you want to know what date these cards were manufactured, when you're looking at Amazon and you're looking for the date, just do a search for ASIN. The ASIN number right next to it or right below it will be the manufacturer date, which is an approximation of when that product became available. Why is that relevant? Why is that important? Well, one, you want to know the product. You want to know the date it might have been available, and it'll help you mark in time when your chipset came out for your particular motherboard, whether it was before or after. Now, I'll tell you what these are made for, in case you didn't know. These cards are all made to work on a high-end desktop. What's a high-end desktop? Okay, X299, X399, TRX40, and WRX80. And if you haven't heard about the WRX80, that's the new Threadripper Pro. And I mean, that's going to be a hot topic and a hot commodity. And for those interested in this, the new ASUS motherboard on the WRX80 is going to include one of these cards, which is the third card, not the one we're talking about, but it's PCI Express 4. Okay, let's start with what's the difference in the 3. There's 2 major differences. The first difference is the orientation of the drives. 1, 2, 3, 4 from the bottom, or 4, 3, 2, 1 from the bottom. The second differentiation came in with a new power source. This version 2 is good for up to 14 watts for the 2-phase power solution. Now that's the same as on this version, but again, this version changed the orientation of the cards. This is the card we're going to look at. This is PCI Express 3, and because of the questions we've had about this particular card, our original intention was to put this on an X399 because it's PCI Express 3.0, but someone said I had one of these cards version 2, which is PCI Express 3, and I tried to put it on a TRX40 motherboard and it wouldn't work. Well, you know, if you didn't go through the process, that may have been part of it. What's required to make this to work? Well, the card requires a 16-lane slot. What does that mean? Because these, and that goes to the question of the drives that are supported. What kind of drives are supported on these cards? There's 2 types of SSDs. One, the old style that we've graduated from, is the SSD. That's a SATA interface, and I'll get more into that in just a minute. The new style that these cards support and only support is the PCI Express M.2 NVMe. What's the difference? This is a regular SSD, and the difference between an SSD and an M.2 SSD is the packaging. This packaging for an SSD is the form factor that works in laptops, desktops, and the way we use these, I put these in a holder so I can put it in the desktop, but I have to use SSDs because that's what our recorder that I'm recording this meeting with right now, this tutorial, that's what these use. Now, I normally use a 500 or 600 gig drive. This happens to be a 2 terabyte. So the first difference is the packaging, but the next difference is the speed. We've gone from spinning drives to SSDs, changing the format from a 2.5-inch drive to an M.2. So you change the format, and then you can change the speed, but then you change the connector. Now they plug in, it looks like the same slot, but they're not. There's a notch on there that makes the difference. So you're going from a drive like this that's 6 gigabit to 600 megabytes. And I have to look at that. I've got it written down because I keep a lot of this in my head, but some of it, you know, I have to see it. I do this a lot, and I've been doing it. As somebody said, well, you know, how many questions have you answered on this? Probably 1 billion. I said, well, it feels like 30 billion, but all I can say is, you know, 30 billion served. I hope we do 30 billion more. But the purpose of this today is to update the first one because we did the first card, the Hyper M.2 x16. That was about doing a non-typical RAID. What do I mean by that? I'll get more into RAID in a minute, but I'll just say a non-typical means if I've got 5 drives on the machine, 4 drives are on this card, 1 drive's on the motherboard. The purpose of that was to not have that 1 drive in RAID. The purpose of that was for these 4 drives to be in RAID. Okay, we're not doing RAID with this. We're just going to talk about the cards. We're going to put one in and talk about the technology. I'll do a follow-up to video of this right after this, and we're going to do a RAID. but it's going to be just 4 drives, so it'll be a typical flat out-of-the-box RAID. So the big difference you're looking at, you go from a SATA drive to an SSD, it's still SATA 3, but when you change the packaging and you go to an M.2, is it an M.2 SSD or is it an M.2 NVMe? What's the difference? Well, in terms of speed, for the first generation PCI Express 3, 6 gigabit, 600 megabytes, we go 3,500 megabytes, then we step up to 5,000 megabytes and 7,000 megabytes. So you want to get whatever according to the technology is, and in terms of bang for the buck, if someone says, okay, which card should I buy? The first version card is not available, but I'm going to have the link up so you can see the technology. These two are the ones available. A lot of vendors sell them. So I would say if you're buying this, I would buy according to the technology that your computer needs, that your computer can support. In other words, if you got PCI Express 3.0, you want the version 2 card. If you have PCI Express 4.0, then you want the generation 4 card. Now, if someone says, okay, well, I've got PCI Express 3, but I'm thinking about maybe upgrading later, why don't I just go ahead and get the generation 4 card? You can do that. It's going to cost you more money. This card's less expensive. Change one thing changes everything. And I would only buy what I can use. For example, we're going to put this in a PCI Express 4 computer. We're going to go through the specs. I will only get the speed that this card is capable of. Chain is only as strong as the weakest link. So if I put PCI Express 4.0 second generation drives on this card, they are neutered because this card is PCI Express 3. It's as fast as it can go. Now again, the chipsets, X299, X399, TRX40, and WRX80. Those 4 chipsets. There is a document that ASUS has, and when people come ask me this question, I go through the hierarchical structure. I need to know the brand, model, and usually the revision of the motherboard. Because number one, if it's ASUS, ASUS has this document that lists what they support. ASUS will support other motherboards of their making because this vendor is on top of this more than anybody else. Because once you get past a 16-lane slot, the second thing you have to have is bifurcation. What's bifurcation? From the Latin term forca, to fork, which means to take something and divide it. So from 1 fork to 2 forks. So what you're going to have is a 16-lane slot, which is 4, 4, 4, and 4. You're going to bifurcate it. So instead of it being all 16 lanes, each one of those drives. How does that figure? Okay, an M.2 SATA drive is 1 lane, 1 PCI Express lane. And I've seen some vendors refer to that as a port. I don't get that. But anyway, as it goes for a lane, 1 lane for an M.2 SSD, 4 lanes per M.2 PCI Express NVMe drive. So there's your big difference. So if you're going to have 4 lanes, you're going to have 4 drives. That's 16 lanes. That's 1 slot. Now, will this work on an X570 chipset? You have 1 16-lane card slot. If your video card goes in another slot, it can't go in slot number 2. Why is that? If you put that in slot number 2, because of shared resources, that first 16-lane slot will drop down to 8 lanes. And what does that mean? That means you'll only see 2 drives. Now, if you only see 1 drive on this card, it's not configured. If you only see 2 drives, that's all you got. This document I want to show you explains all that. And the picture they're going to show you shows the difference orientation of the drives, but it's showing this new card because they've gone from changing from 1, 2, 3, 4 to 4, 3, 2, 1. On the next one, on this card, they've turned them at an angle. And by turning it at an angle, they've done what ASRock has done, and supposedly it gives all the drives equidistance back to the bus. Does it matter? It's a bigger card. It's a more expensive card. But this is the card we're going to look at because this is the one everybody's asking about. So I'm going to open these up, show you the differences. Again, there are no differences in these two. If you're buying one, you want to get this one because this can handle the newer drives, the higher capacity drives that require more power. Now, if you get one of these first generation cards, you want to make sure that if you put the newer drives in higher capacity and you need the wattage, well, you've got that third power connector on your motherboard called the PEG connector. That's for PCI Express graphics. That means if you put a lot of cards in all those slots, plug that power supply in so you're going to have power to this card. So let's take a look at this card and see what we got. Now I'm going to have to suit up and put my gloves on. I have anti-static gloves on. And for those that don't think that's necessary, that's your choice. Intel was the one that said we need to do this, so I do it. And it's been this way ever since we went from pin grid array to ball grid array. And for those of you that are having faults or failures and they are random, that's an electrostatic discharge. So I'm going to avoid that. That's my choice. And another thing, for those of you that talk about peeling the labels off, I'm not going to do that. If those want to do that, that's your choice. The vendor cannot tell you to leave it on. And if you think you're going to get better performance with that off, we've talked about that with some of the drives. If it's copper, it's there for a reason, it's a purpose, and it's part of the heat shield. If it's just a label, we look at a lot of drives and do a lot of configurations. So I leave those labels on so I can tell who's on first. Because one of the other questions that got asked was, one manufacturer says different than what I had told people in relation to putting the drives on. So, and I believe it was a different brand drive where instead of 1, 2, 3, 4 being sequential, it was like 1, 3, 1 and 3, and 2 and 4. So what we're going to do is take this card, we're going to put 4 different drives on so we can see which drive is where, and we're going to plug it into an 8-lane slot so we can see the 2 drives that are seen at 8 lanes, and that will tell you how this card sees those, so that if you only have 2 drives, what slots they go in. Proof's always in the pudding. Once we get through showing that and we identify that, then we'll put it in the 16-lane slot and we'll continue on down that path. First thing is a 16-lane slot, next thing is bifurcation. On PCI Express 3.0, bifurcation is a pretty straight, simple thing. It has to be set manually. But on PCI Express 4.0, since we're on the Gigabyte TRX40 Designare Motherboard and we did our BIOS update, it's automatic. What does that mean? That means when you plug in that card, it automatically configures and distributes those lanes accordingly. You don't have to set it manually anymore. So what we're going to find out, what we want to check, is when we put this in, the TRX40 Designare, will it recognize automatically? Because if somebody put this in a TRX40 motherboard, something other than the Designare, if it didn't automatically recognize, then you have to go in and manually set it. I can give you the blanket statement, but you have to know what the specifications are, and if something doesn't work, how to fix it. That's what that's about. So the first link we've got is the first card. The second link will be the second card, the third one, and on down the line. And I've got a couple links that take you also into the respective cards for the manuals that go with them. And the most important link is the last link that talks about the other motherboards it works with. Now, I've already told you high-end desktops, and I've mentioned to you about the X570. I've got one gentleman that I'm trying to help with an X79 chipset, and this can be done on an X79 chipset, but you got to have a BIOS mod. I had a gentleman, I don't know, a year or two ago that asked me about that, and he found somebody that does BIOS mods. So the gentleman I'm talking to right now asking about a BIOS mod. Omar, you got to find that person. I don't recommend doing that. It's easy enough to brick a motherboard doing the right BIOS, let alone trying to put in a BIOS that's been modded and not brick the motherboard. So I don't advise it. But remember, there's only so many resources for PCI Express. When you allocate a resource for something, that means you have to take a resource away from something. So you have to understand that allocation, and whatever you take away and what you're getting, is it worth it? That's the problem with a lot of the chipsets. That's why we recommend the newer chipsets that these are made for, high-end desktops. Now the next question that comes up, because we're answering subscriber questions, will this work on a Mac? Absolutely not. If you want this on a Mac, you've got to have a Sonic card. Why is that? The Sonic card, and I'll put up a link to it, does 2 things. One, a 16-lane slot, and that's a requirement for these. But number 2, it's self-bifurcating. Now, there's another card that does 6 drives. I'll have to check and see if it has Mac support. I'm not 100% sure. But we're going to be looking at that drive very, very shortly. We got to get through some of this technology, because what's coming down the pike here in a couple of months with the Threadripper Pro is going to blow the doors off of everything. So we need to get through this kind of stuff before we get onto that stuff. And yes, we still got the capture cards and all the sound audio interfaces to do, so we're getting there. But anyway, back to the Mac. HighPoint also has a card that will work on a Mac. These cards from ASUS will not. The one from Gigabyte will not. The one from MSI will not. And the one from ASRock will not work on a Mac. You've got to have a Sonic card. It's got to be a self-bifurcating card. And I will double check, and I'll get a link up, like I said, to the one from HighPoint. So to keep all this kind of stuff straight, we're going to open these cards up. One of these has memory on it, and I'm going to change the memory so all 4 of them are different, so we can plug this into an 8-lane slot and see what we've got. And then from there, we're going to proceed and do a Windows bootable RAID. Okay, let's open up the cards. Okay, this is version 2 on the left. We'll get that out. This is version 1. We'll get that out. One for those asking, there are no drivers. There are drivers for RAID, but these are not RAID cards by themselves. These are strictly I/O cards, so I want to make that clear right off the bat. These are just I/O cards. In other words, when we install this, JBOD. JBOD, just a bunch of disks. So when we put this in with the 8-lane slot, we'll check it, but then when we put it into the 16-lane slot and bring it up, we're just going to do a straight install. The next video that follows up from this, we will do the Windows bootable RAID. So any distinctions or something I missed, you guys ask. That's what we're here for. I want to try to make this as simple as possible for you. And for those that think I talk too much, well, believe me, there's a whole lot more, but I'm trying to keep it simple. And then the last card. You know, the nice thing about this, used to you could go to the store and take a look at a box and read, and that's kind of hard to do even with some of this. So it's kind of what we're doing here. We're going to look and compare. So I'm all set up. I'm good. I'm grounded to the wall. That's the first one. Now the only difference we're going to see in the version 2, and this is the one we're going to be installing that I'm holding right now, there's going to be a serial number on the back. The PCBs are different, and I'll highlight that information, because if somebody buys one of these used, you're more likely to get a version 1 used than you are to get a version 2. But hey, if you get one and it works, it works. Just remember to plug in your PEG connector so you get enough power. The PEG connector should provide enough power. This is the version 2 card. This will put out 14 watts, as well as the new version 4 PCI Express 4.0 version will put out 14 watts. This original one was less. I don't know if it was like 10 or 12 watts, but with the larger capacity drives, right here is where most people are going to be. So what we're going to do is take a look down here at the number. There's a number on both these, and I'll hold them one above the other so we can see them both at the same time. And remember, the new one's on top. That looked like SF15, but now that we've zoomed in on it, it's SFIS. This bottom one also says SFIS, but if you'll notice where the silk screening is done, how large this is, how tiny the print is, and if you notice how small this box is, but how large the print is. So they both say the same. Now we're going to turn them over, and the only difference I noted on the back was a sticker that identifies the two cards. This is the original Hyper M.2 x16 card, and this is the other card, Hyper M.2 x16 card version 2, both made in China. And they have different sticker numbers on top. Let's see how those compare. Yeah, those are different part numbers on the back too. And the one on the bottom is the newer card. See how close we can get in on that. So the original version 1, that's 33, 45, 46. And this other card is 42, 6, 333. I won't bother reading the rest of the numbers. So the first thing you'll look at is that. Now if we look on the PCB where there's a revision number, now again this one on top is the original, and that's a PCB that says CAN. Now they look exactly the same. ICES-3, ICES-3. There is on this one being the top one, being the old one, there is this extra stencil on the PCB that says 940-V with E307069 GE-1. There's nothing like that on this other card. I'm zoomed in pretty tight so you can see what I see. This is the version 1, that's the version 2. So that's the first thing you'll see. There's nothing written right there. So for anybody buying a used one, there's not really very much there to tell, other than on the front where you're looking at the edge connector. The number is a little bit larger, but looking on the back, there's a paper sticker you'll be looking for. All around they're the same, including on the business end. We'll take a look at that, which is the same as the larger card. All around they're pretty much the same. They have the same thing on the business end. From the bottom up, they're both numbered the same way. But the difference you'll notice is the orientation when I take the lid off. So you got the on-off for the fan control, and you got 1, 2, 3, 4. Now I will say one thing about the Gigabyte. On the version 4 card, which is large, and if you notice the striations on this at an angle, I guess that's their way of letting you know that those drives are also on that angle. The reason I mentioned the ASUS Quad card is on the Gigabyte RS M.2 card. If you install their application, which I detest and I suggest not, but if you're brave enough to install their software, their application will let you control the speed of that fan. So if you want to give it a shot, but if you get a BSOD, travel at your own risk. I don't like any of the Gigabyte software. I like their hardware, but don't like their software. So we've kind of looked at all three of these, and we're going to be working with the version 2 card. So now what I need to do, I say we'll keep going. I'm going to take the lid off all three of these so you can see the difference. So then if you decide you want to get the other card that's PCI Express 4, that's your choice. But remember, the PCI Express 4 version is more expensive, and even though you have the spec that'll do PCI Express 4, which means it'll do 5,000 megabytes, or if you hit the second generation drives, it'll do 7,000 megabytes per second, burst mode. It'll only go as fast as PCI Express 3, so it is what it is, but that's your choice. So what I got to do is turn all three of these over, and we're going to unscrew the lids. Now here's the fun part. I will say on the version 2, well, the version 1, version 2, as I look at the back of this, it's interesting. I have these two cards sitting the same way, and you can see how they flip the orientation of the cards on the drive based on the screws. It's kind of wild. Take a look at this. And I hadn't noticed this till I was doing it. Okay, here's the edge connector, goes in the case. Here's the set of screws, and here's your three right here. So if your connectors are, say, right here, that's probably the drive, which is 2280. That extra set of screws over here is on this end. So they have flipped them, which is curious. I'm eager now to see what it looks like on the other side. But I had to point that out because I hadn't noticed it till just now. You know, we always say change one thing changes everything. Anybody getting ready to build a computer right now, I would strongly encourage you to build a high-end desktop. And because of what we know about resource allocation, you know, the X299 was great, but you get so much more if you go with the TRX40. Now, of course, we built with the TRX40 Designare. The X399 was great, but it's just, you get so much more. And we've already had one user that went ahead and bought one of the Lenovo's. She said, I'm going to get that in a configuration that I can get the bones because I need something now. And then she'd upgrade it later, which, you know, made a lot of sense. I would encourage anybody that's interested in a WRX80 to go take a look at that Lenovo and do the what if through that configurator. You'll see what components are available and how much you can go, but how little you can go. In other words, she got a system with 16 gigs of RAM. I couldn't believe it. That thing will support 1 terabyte, but she got it with one stick of 16 gigs of RAM, which made good sense. Get the box, get it up and running, change out the RAM later, get the least amount. I'm real surprised that that would work with one stick. Number 1, Phillips. Okay, good to know. Now again, the ASUS TRX40 and then the ASUS WRX80. You can get an ASUS WRX80 with a quad card, and boy are they proud of it. Or add your own quad card later. That'd be my advice. And now the Supermicro we haven't talked a whole lot about, but the Supermicro will be available in 2 versions. One, you can get just the motherboard on the WRX80, or you can get the whole machine built up already, which I found kind of curious. And for those of you that have seen the update we did on the WRX80, you can take a look at that and see the link. I think I've got both listed. But don't, someone let me know and I'll get it up. And also now we have an idea of the price of the ASUS motherboard, which is pretty realistic for what you're getting. We have an idea of the processors. We still don't know what the Supermicro prices are, and we still don't know what Gigabyte's prices are, but we'll find out pretty soon. Now these drives that are on here are the drives that we used originally on this card, so to keep apples and apples, we put them over here, keep everything simple. And then this card, as you can tell, we haven't used this one yet. It still has the protective covers over the pads. And if you need more pads, there's a part number on that, so you can order more. Pretty good size heat sink on all these. Now, as we look at the front of these, we can check the orientation of these drives. If you notice on the original card, the connectors are on this end. Here's where your rear I/O panel is at, and there's the connectors. Whereas on this card, they flipped it, and you see where the screw holes were. We were looking at the back side. Here's your edge connector, and also here's your connectors for the NVMe drives. Now, I suspect that was changed for heat because you got your cache, and then you have your memory right here. 2 pieces of memory, 2 pieces of memory. Right through here is your cache, and your controllers will be right here. So they've directed this so the heat, the most heat would be here instead of having most of the heat down here. So from a design point, that makes good sense. Now over here we had the orientation, and these will take up to a 22-110. That's the format. We're talking about the size of the drive. 22 millimeters wide, 80 millimeters long. Pretty small packaging. The only thing smaller than that is our little, like our Wi-Fi cards. They can get memory in that size too. We'll be seeing that in the future. About as big as your thumbnail. But right now, this package is pretty tiny as it is. And we've had this packaging for NVMe PCI Express now, I guess going on, about 6 years? When we originally got that, and that's something you want to think about, another part of the spec, PCI Express 3 versus PCI Express 4. If you try to put this on an older chipset that's, say, 10 years old, like the X79, that's PCI Express 2.0. Remember that. What does that mean? That means you're not going to get the bandwidth that even 3,500 megabytes is capable of. You're going to get about half of that, which is about 1750. When I tell someone just keep it simple and get another motherboard, because you can break a motherboard updating a BIOS without it being a modded BIOS. Travel at your own risk. But if you're going to use an older chipset, you have to understand the technology, what you're getting. Even with a BIOS mod to get those lane allocations associated, you're not getting the bandwidth. So it's kind of like, what's the point? Anyway, thought I'd throw that out. So as we look at the card, I can zoom in on this and I'll show you the socket identification. Socket 1, socket 2, socket 3, and socket 4. Now when we look at the other card, I don't see that stenciling. So all they did, when they flipped it, by flipping it, the stenciling we had over here on the right, we don't see that same stenciling over here on the left. The stenciling for these may be underneath the drives. I'm not real sure. Now on this other card, the PCI Express 4.0 card, where they've turned the drives at an angle, these are labeled from left to right. So in other words, here's your I/O connector. So you've got 1, 2, 3, and 4. All right in a line, all at an angle. So each one has equidistance to the bus. The fan on all 3 looks pretty much the same. Change one thing, changes everything. So on this card, I'm going to pull some of those drives off so we can see where things are. I'm going to start with the bottom slot, pull that loose. Let's take a look. There it is. There's our numbering right there. I'll set that down and zoom in on that. So right there's number 4. So what we have with the two cards, the original one, it was 1, 2, 3, 4. Then they flipped it over and flipped it upside down. So instead of going from the card slot 1, 2, 3, 4, on version 2 from the card slot, it's 4, 3, 2, 1. Wow. So they flipped it left to right and they flipped it top to bottom. Curious. Very curious. And what we want to figure out is what the orientation is, if these are configured as 1 and 3 and 2 and 4, or if they go 1, 2, 3, and 4. So we're going to check slot lane assignment. So I'll just take that drive out and set it aside. Take another drive out and set it aside. Now these are 500 gig drives. So what I'm going to do is put a couple of drives on here that are PCI Express 4.0 1 terabyte, and the third one will be the other drive we have, which is PCI Express 4.0 2 terabyte. And all three of them are second generation drives. I'm curious, but when I get finished testing, then I'll come back and put these 4 drives just like it is. Now if you're doing this, you're probably going to want to put the largest drives you can get, but I'm doing this for a test. And I hope you understand why we keep the labels on, or else I wouldn't know who's on first. So we have a Sabrent Rocket 4 Plus, we have the Samsung 980 Pro, and we have the WD Black. So we're going to use these 3 drives because they're all going to have a different label. And with those 4 drives on, 2 will be one brand but different size, different spec, and the other 2 will be other brands. So when we look at that in the BIOS, we'll know immediately where they are. And because we know the slot lane assignment, we know the configuration where connector 4 is on the bottom, connector number 1 is on top. What my expectation to see in the BIOS is the hierarchical structure of 1, 2, 3, 4. Number 1 being that 970 EVO, 500 gig. We're going to see. And I'll put the largest one right next to it. That'll be the 2 Samsung drives. That'll give us some idea. So we'll put the only way to know is to test. Remember answering subscriber questions. What a hodgepodge. Okay, so then we'll do the WD Black next, and we'll put the Sabrent Rocket 4 in slot number 4, closest to the bus. This is one of the reasons I wish vendors did better packaging, because we swap drives in and out a lot, and I need some way to store them other than the way we do. Okay, the WD Black, and for the Sabrent. And the Sabrent happens to be double-sided. Now there's a pad down here. I hope that pad doesn't interfere with this drive. We're going to see. It'll work. A little tight, but it'll work. I don't want to take the pad off of the card. I think I can make that work. A little gentle persuasion. I think we can also get these other drives out of the way because we're not going to be using them. We've done what we needed to compare, and they serve that purpose well. Because when we get through with this, we've got a computer coming up here. Yeah, these black screws on the back all work best with the number 2 Phillips. And I didn't notice till now, but they have little nylon washers on them too, which is nice. Keeps them from scoring and scratching the back. Especially important around some of those tiny little traces on the back of the board. That's one of the nice things about video. We couldn't do this with a live meeting. It takes too long. But this way, with me doing this, or even a live stream, with me doing this as a recording, I can cut out the bits that you don't need to watch that would be very boring and cut to the chase. In other words, at the moment, I'm at 1 hour and 11:35. 1 hour, 11 minutes, and 35 seconds I've been recording. And you will probably only see about 15 minutes of this. And yes, we'll do another video, follow up, about this particular card. But the next video after this is going to be the Windows bootable RAID. Unless we're going to do Windows bootable RAID on the TRX40. Oh, what a good idea. Wish I'd have thought of that. Okay. If we're going to do the RAID, the Windows bootable RAID on the TRX40, we'll do it on card number 3. Wish I'd have thought of that. Gotta have a little fun with you guys. And I want to thank everybody for watching. Okay, that's back together. The screws are 2, 4, 6. This will go back in the bag until we get ready to take the next step. Now, why would I use the ASUS versus the ASUS card to do the Windows bootable RAID? More people are asking about the ASUS than they are the ASUS. It is what it is. But whichever card I use to do that with, same technology. Okay, that one's put up. The reason I need to get this cleared out is because I got to get the computer up here, so I might as well do this now. That's interesting. The version 1 card did not have any protection on the screws. There are no washers. The version 2 card has no washers, but the PCI Express version 4 does have washers on the screws that hold that heatsink down. Curious. We've been absolutely amazed at how many people have been interested in putting in one of these Hyper M.2 quad cards. Just floors me. Never take anything for granted because you never know who you might be able to help. So far, the only thing I've needed has been a number 1 Phillips tip, magnetic tip, which is nice. We get through this, we'll go back over and do a summation, and I will include to reiterate what we've already done for a wrap up. I can tell you right now, likes or dislikes, man, this is really cool stuff that we get to do this. Kind of blows my mind. Okay, we have 4 memory sticks on here. One's the 970. let's go through what we've got. We've got 4 different sticks on here, and why are we doing that? To answer the question, how these slots are allocated for lanes. This is all about slot and lane assignment. So for this one 16-lane slot, it'll be allocated 4x4x4x4. In the slot number 1, which is at the top of the card, we have a 970 EVO. Okay, we'll get 3,500 megabytes throughput out of that, which is the spec for PCI Express 3, because this is version 2 card. That's 500 gig. This is a 2 terabyte drive. This is a second generation, so this 980 Pro is capable of 7,000. And this card, but we won't get that. The best we can get is the 3,500. This card is also capable of 7,000. This is a second generation drive. And this is a 1 terabyte WD Black SN850. So the Samsung 980 Pro, the WD Black SN850, and then we have a 2 terabyte. This is the Sabrent Rocket 4 Plus, 2 terabyte. This ought to be pretty wicked. So this is going to help us to test and verify a couple things. Again, our slot and lane assignment, and putting it in an 8-lane slot versus a 16-lane slot. So you can see it firsthand. I have to force that rocket down just a tad bit to get that to push down and compress that pad. But it goes, it works. My expectation on these 4 drives is we'll see them 1, 2, 3, 4, which will be Samsung in an 8-lane slot. And then when we go to a 16-lane slot, then we'll see the other 2, which will be WD and Sabrent. We're getting ready to find out. It's amazing how heavy these things are getting. And it's also curious to note on the WRX80, the ASUS board, 12 pounds just for the motherboard. That's wild. Okay, computer's up here, got it spun around. I found using that Lazy Susan makes it easier when I'm moving stuff around, so a little tidbit of information. I put it up, put it on the Lazy Susan, I can spin it, and I can also slide a little bit, pick it up, pull the Lazy Susan out. So, hope that helps. And I'll put a link up to it. If I forget, somebody remind me. Okay, the machine we're going to be working in, this is the, just to refresh everybody's memory, this is the Gigabyte TRX40 Designare Motherboard. We have 2 16-lane slots, and then we have 2 8-lane slots. This 8-lane slot down here where my right hand is at, we cannot use. So we're going to go into this first 8-lane slot so that we can see what we'll see, which will be 2 drives on an 8-lane slot. And it should be automatically configured because the BIOS is still the default, which is auto. So when we go into the BIOS, there's 2 places we can look, and we should see 2 drives. And my expectation for the 2 drives, let's see what we see. So we're going to go for this slot right here. Now that's the boot NVMe drive, and this is the second NVMe drive that would normally be here. Nothing's in there now, and that's the 16-lane slot. When we get ready to boot this and configure the drives, we'll put it there. We're using this to test in the 8-lane slot so we can see who's on first. Out comes the card again. And because this is a PCI Express 3 card going in PCI Express 4.0 motherboard, it should automatically recognize. But to reiterate, if it does not, then it needs to be manually configured. Okay, video, network, keyboard and mouse, and I will plug in power. Verified my connections, nothing in the way of any of the fans. Everything is secure, so when things come on, we'll be good. I have not completely taken out the Thunderbolt card, but it is in a secure spot where it will not interfere or influence anything else. So I'm ready now to turn on the power supply, and I'm ready now to turn on the computer. Here we go. So as the computer's booting up, as soon as it's up, I'll take you over to the monitor. Okay, there'll be 2 places we need to look. First thing we can do is we can go to boot. So that did not automatically recognize. That should see 2 drives. I'm going to go into easy mode F2 to look at the connectors. The SATA, okay, PCI Express 4.0x4 at 4x4. Okay, what I wanted to verify was that did not automatically configure, so we have answered a question. If you take a PCI Express 3.0 card and put it on a PCI Express 4.0 motherboard, I have seen some devices auto-recognize, like the Thunderbolt card. It's PCI Express 3, it auto-recognizes. Well, these quad cards still have to be manually set, so we're going to do that in the BIOS. That's what I wanted to verify by looking at these connectors on this board. Because we're in an 8-lane slot, we should see 2 drives. We only see 1 drive. Right here where it says PCI Express, the first slot is open. The second slot, which is an 8-lane slot, says PCI Express by 4 at 4.0x4. So we've got to change that. The second 16-lane slot is where the video card is, and there's nothing in the other slots. So we're going to go back into the BIOS under F2, change mode. We'll go to Settings, I/O ports, and we will change PCI Express by 8_1 from auto. We will set that to 4x4. And while we're at it, miscellaneous, so I/O ports and the boot. Now that's interesting. That sees the Samsung 980 Pro 1 terabyte. That 1 drive that's seeing as the first is actually in the second slot. So I find that quite curious. So now that we've gone into the BIOS under Settings, I/O ports, and changed that to 4x4, we need to reboot. And then we should see 2 drives. I expected to see a 500 gig drive there, but we didn't. We saw a 1 terabyte drive. That's really curious. So those are not 1, 2, 3, 4. Let's see how it looks when we see the two drives. That's interesting. I learned something new. Okay, we're going to reboot. So we do an F10, and this is what I like. Whenever we make a change in the BIOS, it'll show the last thing that was modified. And this says right here, PCI Express by 8_1 bifurcation from auto to 4x4. Because remember, there's only 2 NVMe drives that we should be able to see in an 8-lane slot. So we're going to say yes. We'll come back into the BIOS and see what we've got. I got to write that one down because I didn't expect that. I expected to see that 500 gig drive, but we didn't. We see a 1 terabyte drive. So that was number 3. Okay, we got post, so I can see why somebody had difficulty with that. Okay, I'm going to look at boot, and we should see 2 drives. And we do. Under boot, the drives, that's the boot drive that's on the motherboard. But here's the 2 drives that are on the quad card. And 2 drives are all we should see because we're in an 8-lane slot. PCI Express 4.0 motherboard, PCI Express 3.0 card. Now it shows the first drive 500 and the second. But with that set as a 16-lane slot, or excuse me, as an 8-lane slot, the first drive we saw was that 1 terabyte. That's curious. And the only thing we had to change as we look at I/O ports was PCI Express by 8_1 bifurcation 4x4. Okay, now the next thing I'm going to do is I'm going to go into F2 BIOS. So we'll press F2 in this view, and right here we will look at PCI Express 3, and it says PCI Express by 8_1 is now set for PCI Express 3.0 by 4 at 3.0 by 4. So whoever installed a card, all they had to do was go in and set it manually. That's really interesting. So you can make a blanket statement about how things are supposed to work, but you know, it is what it is. Understanding the technology is what it's all about and what you have to do to make it work. So we've taken so far where we're at. We've taken a card that has 4 drives on it, PCI Express 3.0. We've installed it on a PCI Express 4.0 motherboard. Now, PCI Express 3.0 is manually configured. PCI Express 4.0 is automatically configured. And my expectation was, with the BIOS update, that PCI Express 3.0 would automatically be configured. It's not with that card. It is with the Thunderbolt 3 card. It's automatically configured because it sees it the way it's supposed to. But with the PCI Express 3.0 M.2 card, that has to be set manually in the BIOS. Pretty simple. Okay, now what we want to do is save this, power down, put this in a 16-lane slot, go back and look at it, repeat this. Then we'll go into Windows, we'll have our 4 drives, then we should be done. Cool. So I've got my F2 back to the regular mode. Look again at my boot. So I'm going to do F10, save configuration because I've changed nothing. We're going to power down. It's always good when you go in the BIOS to save it so you don't have any glitches. And as soon as I hear it post, then I'll press the power button. There's post. I'll press the power button. I'm holding it down and it powered off. Turn off the switch, hit the button again to drain the power. It lights up like a Christmas tree. Power's off. Okay, now just to be safe, I'm going to pull power. I can leave everything else plugged in. So now we need to pull that card out, swap it over. I don't know about y'all, but I found that quite fascinating. I wouldn't have done that if it hadn't been for this video. I wouldn't have known that if I hadn't have done this. You know, we learn by doing. I always say, you know, change one thing changes everything, but I know enough to know I need to know more. So that's what we're doing. And then we have the hypothesis of an expectation. We'll see how that plays out. I got to tell you, I got a little bit of Missouri blood in me. My grandmother always said, show me. That's what we're doing. We are now in a 16-lane slot. We've got to go back and do the same thing, which is reboot, because we're in a 16-lane slot. We got to go in there and bifurcate, which means change that from 16-lane to 4x4 by 4x4. So let's do that, reboot. Then we'll go into Windows and we'll have 4 drives. Then we'll be done. All right, plug in the power, verify what we've done. Cards installed, screwed down, secured. Nice clearance with the processor. I kind of like having that video card down there. It works and allows us to do our testing. Okay, cards installed, screwed down, power supply is plugged in, turned on. All we need to do is turn on the computer. Power supply is turned on, turn on the computer. Back in business. So while everything's coming up, as soon as we're up and running, waiting on the post, got to go to the BIOS. Remember, we have to configure the slot. We change slots. Okay, system's back up. Let's go to the BIOS. We'll take a look at boot, and we see 1 drive. So we'll go to settings, I/O ports, and we are in that first 16-lane slot. So we've got to change that to 4x4 by 4x4. Now the 8-lane slot we were in a while ago, we're going to change that back to auto. We're not going back to that. We did that for a test. So the first 16-lane slot, bifurcation, 4x4 by 4x4. Now if we were on an ASUS motherboard, the setting won't say bifurcation. It'll probably say Hyper or Hyper Quad. The Hyper is talking about the Hyper card. That's what you're setting that for. So little tidbits. The same thing, it's just branding. Confusion? Absolutely. But hey, that's what vendors do. Now I also want to verify, so I'll do F2. And I'm going to look at PCI Express, and I'm in that slot which shows PCI Express by 16_2, 4.0 by 16, 4.0 by 16. And when I reboot, that'll say 3.0. So we'll go back to F2 to change back to the regular BIOS. We'll press F10. It shows the two things I've changed, which I put slot 8 back to auto, and I've taken the first 16 lane slot, and the resource allocation is 4x4, 4x4. We will say OK, and we'll reboot. And when it comes back up, we'll go back into the BIOS, double check this before we go to the operating system. We're just about there, hang with me. And for those of you that build a machine, even with a quad card that's PCI Express 4.0, depending on your BIOS and depending on what's going on, you may have to manually configure that card. So just be aware. But with PCI Express 4.0, on the Gigabyte WRX80 Designare, it will automatically recognize PCI Express 4.0 card and allocate resources accordingly. But with a 3.0 card, we're having to set it manually. BIOS, let's look at boot. We now see 4 drives. So we see the 500 gig drive, the 1 terabyte, both Samsung, then we see the WD to the Sabrent. That's really interesting. Let's go to settings, double check our I/O. We're 4x4x4x4. Let's do F2, change the BIOS, PCI Express 3, and it shows PCI Express by 16_1 is set at PCI Express 3.0 by 4 at 3.0 by 4. Cool. So F2, we're back. F10, we are now ready to save configuration, reboot. Now we go into Windows. This is a blast. Thanks for being here. You guys are amazing. Okay, we're booting. We're going to go into Windows, and we're going to configure this as JBOD, just a bunch of disks. That's it. And that'll finish the install. And remember the 3 things we got to do. 1, 2, 3. That's what we'll do. Then we'll have drives that are accessible. The RAID thing is going to be kind of involved, so I'm glad we're doing this to get this out of the way, because there's a whole bunch of other stuff we need to talk about. There's usually 3 places where people hang up on RAID, and there's 3 different types of RAID I want to get into, but that's in the next video. So much stuff to talk about in so little time. I hope you guys are enjoying this. Windows. Okay, y'all know the drill. We got to go to Control Panel once the computer's up. Administrative Tools and Computer Management. Now, we may get a dialog box that pops up when we hit Disk Management. No, it didn't. Okay, so it still sees the configuration of the drives. Normally with new drives, you have to initialize the drive. That's step 1. At this stage, a dialog box pops up, shows you the drive, you initialize. These drives have already been initialized multiple times. In other words, the drive, since it's been formatted, I don't have to do that again. And yes, for the experts out there, you can go back and reinitialize a drive. You can do a low-level format, but beyond the scope of what we want to get into. So what I want to do is double check here and see how the drives are set, make sure they're formatted. Because as you go through the steps, number 1, low-level format. Number 2, format the drives. Then you assign a drive letter, and that drive letter pops up, and those disks are usable. So let's see where we're at. So I have labels on these drives: a Samsung 980 Pro, a WD Black SN850, a Sabrent Rocket, and then we have the other drive right there. Disk 2, it says it's foreign. That's interesting. Now I'm glad that showed up. There's a good example of if you've got a drive that has been used or monkeyed with or whatever before, how do you fix that? I've seen this with drives where someone buys a used drive, and because this drive was in a RAID, it doesn't understand it. So what I have to do is do a low-level format. The easiest way to do that, I can do it with a command from Windows, or I can do it with a version of Linux. And there are other disk tools that will see that drive that let me do it. But I'm not going to get into that. It's a different topic, but that's why we don't see that drive. Otherwise, we'd have 4 drives. So the purpose of this was to install the card, tell you about the technology, and to show you the difference in a 16-lane slot and an 8-lane slot. Talk about the requirements, talk about bifurcation, the chipsets it works in, the chipsets it won't, and the one last document I'll show you is the one from ASUS that talks about the different chipsets. And the picture they show is for the PCI Express 4.0 card, but it's the same for all 3 cards. Same technology applies. But if anybody has questions how to fix this drive, I can tell you that in another video. Hope you guys enjoyed this. So on to the next video. We're out.